All right, let's look at the process of how to solve one-step equations. First of all, what a one-step equation means is that these are equations that you are only going to have to do one thing in order to solve them. It's only going to take one step. All right, let's first consider this equation. I have an x, or it's better to say an unknown, added to 5, and I know it's exactly the same as 29. Notice how I put meaning to my symbols. That's important for algebra. I said unknown is added to 5. And right here I said, and that's the same as 29. That helps your brain to understand what's happening. Let's go ahead and draw a picture to assist. So I'm going to make a triangle for my unknown because it's quick to draw. And then right here I know added on the same side of this triangle is a weight that has a weight of 5. And that ends up the same or balancing the scale with 29 over there. So now to figure out what that weight is worth, I would need to think, okay, if that added to 5 is 29, the inverse operation would be to subtract. I want to know what is 29 minus 5, which is 24. That means I now know this weight would have to be 24. So the value of the unknown, the x, I would say is 24. Now check. Let's have a discussion about what that means. Check is where you figure out exactly what both sides weigh, and you make sure that they weigh the same. This is a cool process because if you will get into a good habit of always checking your equations to make sure they are balanced, then you're basically guaranteed to never miss an equation problem. I mean, that's pretty cool in math. Think about it. You are guaranteed to always know for sure if your answer is correct. So let me show you how the check works. I want to look at this side now, and I want to figure out what does that side weigh? Well, I want to think, what is 24 plus 5? 5 plus 4 is 9, and then 2, so I get 29 here. And then on this side, I don't have anything. That's also, or anything to do, I should say. So that's 29. So I look at this. Are these numbers the same? Yes. That means I know for sure that 24 balances this equation, and therefore it is 100% a correct answer. That's what checking is about. But let's talk real quick about something. Do you notice that the value of my unknown and the numbers in my check are not the same? There are some rare occasions that they will be the same, but rarely. Kids tend to want to make a mistake by coming up with the answer and then just filling that into every box. Do not do that. Another bad habit is sometimes kids kind of skip the check. And then they're upset because they didn't end up getting a good score. Well, like I said, if you will do the check properly, you're guaranteed to always get all your points. All right, let's look at our second example. So now we have an x, so I have an unknown, and I have to take away 8. To show take away 8, there's two options. You can change colors to let us know we're going to take away there, or what some kids do, because you rarely have colors, is instead of drawing a box, now they circle it. Circles mean take away. Okay? All right, and then we've got 14 on this side. All right, so I've got a number, take away 8. It ends up the same as 14. And so I need to figure out what that unknown is worth. Well, I would want to do the opposite operation. What's the opposite of take away an 8? Add an 8. So I do 14 plus 8 is 22. So that means this should weigh 22. So let's go ahead and put this in for the value of our unknown. Now let's check our math. Since I circled this, I remember, okay, do a takeaway. So do 22, take away 8. So I carry, and I get 4 here. 14. So we get 14 on this side. And what do we have on the right side? 14. And those are the same. So therefore, I know my answer is correct. All right, let's look at one more that is dealing with addition and subtraction. This one, I start out with a 6. I'm going to do a box. I've got a unknown, put it on there. And then on this side, I've got a 15. All right, and we know those have to weigh the same. So in order to figure out what that triangle is, I would do an inverse opposite operation. What's the opposite of add? I would subtract. 15 take away 6 is 11. So that now that lets me know that unknown should be 11. Let's check it and make sure. I need to come over here and add these two 8s together. And I get 17. And then on this side I have 15. Oh no, I'm wrong. See the value of the check? You might have saw my mistake I did on purpose earlier, but I did that to help you to see how the check will let you know 15 minus 6 is not 11. That does not work because 6 plus 11 does not give me 15. Let's try this again. 15 minus 6 is 9. So I'm going to change this to a 9 and change this to a 9. And now I'm going to do my check again. 6 plus 9 gives me 15. So now I can change the 15 on this side, and now I know it's correct. 9 is correct. All right, let's look at this one. This is where we really have to make sure we're understanding our symbols. Remember, we've talked about when we have that coefficient, remember that word coefficient in front of the x. Why do I know it's a coefficient? Because it's like they're glued together. In between, I don't see any symbols, no plus sign, no minus sign. That's a coefficient. It tells me how many of those unknowns I have. So let's go ahead and draw that out. I have 7 unknowns. What did those end up weighing? 84. So now I want to, it's obvious, I want to think to myself, 7 unknowns, 7 of the same number. I want to know what number, when I have 7 of the same ones, ends up equaling 84. Well, that's a multiplication concept. I'm thinking 7 times what is 84. If I want to come up with that answer, I do the inverse. I need to think what is 84 divided by 7, which again, I'm back to thinking 7 times what is 84? Well, 7 times 10 is 70. Got to be bigger than 10. 7 times 7 is, 7 times 11 is 77. I think it's going to be 12. I think all of those are equal to a 12. So let's come over here and think. Let's check our work. Just figure out, is 12 times 7 going to give us what we need? So 7 times 2 is 14, looking good. 7 times 1 is 7, plus 1 is 8. I get 84. Look at the right-hand side. We also have 84. So recap on this one. How do I solve it? Do the opposite of multiplication, which is divide. And always check your work. All right, now let's remember what that one means. Fraction bar. I see 8 or x sevenths. Whoa, confusing. Don't do that. Okay, fraction bar also means to divide. That is x divided by 7. Oh my, how do I draw x divided by 7? There is a way, but I don't want to get into that right now because I'm afraid it might kind of confuse you and complicate things. So let's just, on this one, focus on, I'm going to solve this with the inverse operation. Okay, this is division. This is x divided by 7. So I want to do the opposite. I want to do 13 times 7. So I'm going to do that real fast, and I get 91. So that means x should be equal to 91. So to do my check, I want to think over here. If this is 91, whoa, I'm evaluating. I want to think, is 91 divided by 7 give me 13? So I want to check it that way too, and I would do 91 divided by 7, I would get 13, and then on this side I get 13, so I've checked it. I know both ways x is definitely 91. All right, you're going to get to practice some problems yourself. Step 1, see what operation is there. Is that equation addition, subtraction, multiplication, or division? Step 2, think, what is the opposite? Step 3, solve it by doing the opposite. Good luck.